Example sum 1.22. Find the equivalent capacitance between P and Q for the configuration shown below in the figure. Here P and Q point கடையில 1 2 3 4 5 6 capacitors connected பண்ணிருக்காங்க. இத we are going to converted in a single capacitor. Here the 1 microfarad and 3 microfarad are connected in parallel and 6 microfarad and 2 microfarad are connected in parallel. So what is the equivalent C capacitance equivalent connected in parallel? In the first case 1 plus 3 is equal to 4 microfarad and in the second equivalent equal to 6 plus 2 equal to 8 microfarad. So in this diagram the 4 microfarad is 4 microfarad. இது ரெண்டும் combine ஆகி 4 microfarad ஆயிடுச்சு. So இதுவும் உங்களுக்கு என்ன ஆயிரும் 4 microfarad. இது ரெண்டும் combined ஆகி 8 microfarad. இங்கே already இருக்கிறது இது 8 microfarad. So this diagram is simplified into this type. Then this 4 microfarad and this 4 microfarad are connected in series. About 1 by C equivalent is equal to 1 by 4 plus 1 by 4 equal to 4 common எடுத்தீங்கன்னா மேல 1 plus 1 that is equal to 2 by 4 which is equal to 1 by 2. Then 1 equivalent இது equivalent 1 ன்னு வச்சுக்கிறேன். So C equivalent 1 is equal to இதுக்கு reciprocal எடுத்தேன்னா இதுவும் reciprocal ஆச்சுன்னா வெறும் 2 ன்னு கிடைக்கும். Then next C equivalent 2 that is 8 microfarad and this 8 microfarad are connected in series connection, that is 1 by 8 plus 1 by 8 equal to 8 common எடுத்தோம்னா 1 plus 1 2 by 8 which is equal to 1 by 4. அப்ப C equivalent 2 taking the reciprocal we are getting 4. So இது வந்து 2 microfarad இது வந்து 4 microfarad. So இது ரெண்டும் combine ஆகி உனக்கு 2 microfarad ஆயிடுச்சு. இது ரெண்டும் combine ஆகி இது வந்து 4 microfarad ஆயிடுச்சு. So இந்த C diagramல these two are connected in parallel. So C equivalent is equal to 2 plus 4 which is equal to 6 microfarad. So இந்த diagramல இருக்கிற அத்தனை capacitorsம் இப்ப combined ஆகி a single capacitor-ஆ 6 microfarad capacitor-ஆ பண்ணலாம். அப்ப இந்த combinationக்கு நம்ம ஒரு 6 microfarad-அ கொண்டு போய் connected பண்ணலாம் a single capacitance-ஆ. Then next sum 1.23 example, that is two conducting spheres of radius r1 8 cm and r2 2 cm are separated by a distance much larger than 8 cm and connected by a thin conducting wire as shown in the figure. So ரெண்டு ஸ்பியர்ஸ் இருக்கு. இதனுடைய ரேடியஸ் வந்து 8 cm 8 into 10 power minus 2. இதனுடைய ரேடியஸ் வந்து 2 cm 2 into 10 power minus 2 and they are connecting by a thin conducting wire. A total charge of Q 100 nanocoulomb is placed on one of the spheres. இந்த ரெண்டு ஸ்பியர்ல வந்து ஒரு 100 coulomb charge வைக்கிறாங்க. After a fraction of second, the charge Q is redistributed and both the spheres attain electrostatic equilibrium. இதுல ஏதோ ஒரு ஸ்பியர்ல கொண்டு போய் நான் 100 நானோகூலம் சார்ஜ் வைக்கும்போது இங்க ஒரு கண்டக்டிங் வயர் இருக்கிறதுனால இங்கேயும் சார்ஜ் will be redistributed ஆயிருச்சு and both the spheres attain the electrostatic equilibrium. Calculate the charge and surface charge density on each sphere. Then calculate potential at the surface of the each sphere. So first we are in the part A. Calculate the charge and surface charge density. For calculating the charge, we are calculating the potential at the sphere A. VA is equal to 1 by 4 pi epsilon naught Q1 divided by R1. Then the potential at the sphere B is equal to 1 by 4 pi epsilon naught Q2 divided by R2. But when they are connected by the wire, the potential difference is same. ரெண்டு potential difference எப்படி தான் இருக்கும், சேமாக தான் இருக்கும் when connected by a wire. So VA is equal to VB க்கு equal இருக்கும். Substituting this value 1 by 4 pi epsilon naught Q1 divided by R1 is equal to 1 by 4 pi epsilon naught Q2 divided by R2. Then we are getting 1 by 4 pi epsilon naught, 1 by 4 pi epsilon naught cancel ஆயிரும். So Q1 by R1 is equal to Q2 divided by R2. Then what is the value of Q1? Q1 is equal to R1 by R2 into Q2. இதை கிராஸ் மல்டிபிள் பண்ணி மேலே கொண்டு போயிருக்கேன், இது இங்கே வந்துருச்சு. ஆனால் டோட்டல் சார்ஜுங்கிறது Qன்ற சார்ஜ் தான் கொண்டு போய் வச்சேன். இதுதான் வந்து உனக்கு என்னவாயிரும், Q1 plus Q2 due to the conservation of the total charge. From this equation, I am getting Q1 is equal to Q minus Q2. This value should be substituted in this equation, that is Q minus Q2 is equal to R1 by R2 into Q2. Then Q is equal to R1 by R2 Q2. This minus Q2 is coming in this side plus Q2, which is equal to R1 by R2. We are taking the Q2 outside, so R1 by R2 plus 1. Taking the LCM Q2, R2 common எடுத்தேனா R1 plus R2, that is Q. But I need the value of Q2. So Q2 is equal to capital Q into R2 divided by R1 plus R2. இது ரெண்டையும் இங்கிட்டு கிராஸ் மல்டிபிள் பண்ணிடுறேன். So taking the reciprocal, the value of Q2 is equal to Q into R2 divided by R1 plus R2. ஆனால் given dataல R1, R2, Q ஓட வேல்யூ பூரா தெரியும் நம்மளுக்கு. So substituting these values, Q2 is equal to capital Q is equal to 100 into 10 nanocoulomb into 10 power minus 9 into R2 வந்து எவ்வளோ வேல்யூ 2 into 10 power minus 2 divided by 8 plus 2 into 10 power minus 2. So 10 power minus 2, 10 power minus 2 cancel. 100 into 10 power minus 9 into 2 divided by 10. 0, 0 cancel ஆயிரும். So 20 10 power into 10 power minus 9 Q2. That is the Coulomb charge. So Q2 is equal to 20 nano Coulomb. We are calculating the value of Q2. Then we are going to calculate the value of Q1. So Q1 is equal to Q minus Q2. Q வந்து 100 nano Coulomb. Q2 is equal to 20 nano Coulomb. So which is equal to 80 nano Coulomb is Q1. So we are calculating the value of Q1 and Q2. The electric charge density sigma 1 is equal to Q1 divided by 4 pi R1 squared. And similarly, sigma 2 is equal to Q2 divided by 4 pi R2 squared. Substituting the value, sigma 1 is equal to 80 into 10 power minus 9 divided by 4 pi into 64 into 10 power minus 4. Simplifying these values, we are getting 0.99 into 10 power minus 6 Coulomb per meter squared. And similarly, sigma 2 is equal to 20 into 10 power minus 9 divided by 4 pi into 4 into 10 power minus 4, which is equal to 3.9 into 10 power minus 6 Coulomb per meter squared. Then from the equation 1.113, we already know that sigma 1 by sigma 2 is equal to R2 divided by R1. When we are substituting the sigma 1 and sigma 2 and we are substituting the value R2 by R1, we are getting the same value. So the surface charge density is greater on the smaller sphere Compared to the larger sphere which confirm the result sigma 1 by sigma 2 is equal to R2 by R1. The potential on both sphere is the same. So we can calculate the potential on any one of the spheres. So we are calculating the sphere AVA, that is 1 by 4 pi epsilon naught Q1 divided by R1. That is equal to 9 into 10 power 9 into 80 into 10 power minus 9 divided by 8 into 10 power minus 2. 10 power 9, 10 power 9 cancel ஆயிரும். 8, 8 cancel ஆச்சுனா 10. So 90 divided by 10 power minus 2, which is equal to 90 into 10 power 2, which is equal to 9 into 10 power 3 volt. So VA is equal to 9 kilovolt. Then